Hello, teacher. Hello, students. Welcome to today's lesson on solving systems of linear equations in two variables. In our last lesson, we learned how to solve equations involving exponents and radicals. Today, we will review what you have previously studied about linear equations, and we will learn how to solve them when there is more than one variable. If you are ready, students, let us begin the lesson. You probably recall that a linear equation is any equation of the form a times x plus b equals 0, where a is not equal to 0. In this equation, a and b are called coefficients of the equation. For a quick review, students, please solve the following linear equations. As you solve them, keep in mind how many possible solutions you can get for each equation. Go ahead, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure that you found these equations quite easy to solve. Each equation has only one possible answer for the value of x. For question A, x equals 2. For question B, x equals 5. And for question C, x equals 6. Students, let us consider a linear equation where the variable is on both sides of the equation. I am sure that you remember how to solve these. Suppose we have the equation -3 times 2x plus 4 equals 2 times -3x minus 6. Our first step is to expand the bracketed parts of the equation. This gives us -6x minus 12 equals -6x minus 12. When we put this into the form of a times x plus b equals 0, we find our answer to be 0 plus 0 equals 0. What can we conclude from this? There are infinite solutions to this equation for any value of x where x is a real number. 0 will equal 0. Such equations can have one solution, infinite solutions, or no solutions. Now that we have reviewed linear equations in one variable, let us move on to linear equations in two variables. A times x plus b equals 0 is a particular case of y equals a times x plus b when y equals 0. This means that for different values of y, there will be different equations with their own solutions. An equation of the type c times x plus d times y equals e, where c, d, and e are arbitrary constants, and neither c nor d are equal to 0, is called a linear equation in two variables. An equation in two variables can be reduced to the more familiar form y equals a times x plus b. Students, please look at these equations. Which of the following are linear equations in two variables?
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. If you chose answer A as the only linear equation in two variables, you are correct. B and D have two variables, but they are not linear equations. Remember, in order to be a linear equation, you must be able to reduce the equation to the form of y equals a times x plus b. Answer C is a linear equation, but it has only one variable, x. Let us look at the linear equation from answer A. 4x minus y equals 8. We can change this equation to the proper form by moving the y and the 8. Our new equation is y equals 4x minus 8. Suppose that y assumes the values of 0, 1, and 2. When y equals 0, the equation becomes 4x minus 8 equals 0, and its solution is x equals 2. When y equals 1, its solution is x equals 9 over 4. When y equals 2, its solution is x equals 10 over 4 or 5 over 2. Observe, students, that for each value of y, there is one corresponding value of x. This relation is represented by an ordered pair x, y. The set of all those ordered pairs that satisfy the equation y equals 4x minus 8 is the solution to the equation. In this example, we solved the equation for the pairs 2 and 0, 9 over 4 and 1, and 5 over 2 and 2. These pairs are points that we can plot on the xy coordinate system, as you see here. There is a straight line that passes through them. Students, I would like you to solve the following linear equation in two variables for values of y equals 0, 1, 2, and 3. Then plot the points on an xy coordinate system.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Please compare your answers to these. The first step is to change the equation to the form y equals a times x plus b. Therefore, the equation becomes 2y equals 6 minus 2x. When y equals 0, the value of x is 3. When y equals 1, the value of x is 2. When y equals 2, the value of x is 1. When y equals 3, the value of x is 0. When you plot these points, your graph should show a straight line from the point 0 and 3 down to 3 and 0. Did your graph look like this one? Well done. Today, we have learned how to solve linear equations in 2 variables. In our next lesson, we will study systems of linear equations and their solutions. Until next time, thank you, teacher. Thank you, students.